will give an overview of some of the work that they've been doing at Warwick.
Thank you very much. Good morning, everyone. My name is Adebayo. I'm a research fellow with the Secure Cyber System Research Group of University of Warwick. I have a PhD in Information Science from the African Regional Center for Information Science, University of Ibadan, Nigeria, and a Master of Science degree in Cybersecurity from Northumbria University, Newcastle. My background is software engineering. I have deep interest in artificial intelligence and machine learning. I've done projects with Prolog, with OpenVC, with R, TensorFlow, and Keras. Today, I'm going to be presenting resilience machine learning in nuclear application research challenges and opportunities. And please move to the next slide, Laura. And I'll be covering machine learning objectives and algorithms in nuclear applications, open research challenges in building resilient machine learning, attacks on machine learning models, potential areas of focus, and next course of action. Next. Nuclear facilities are important national infrastructure, and they need to be maintained at top level of performance under strict control to prevent accidents that could affect millions of people. From 2004, the International Atomic Energy Agency, IAEA, has provided guidelines for innovation within nuclear facilities to steer the industry towards innovation. And the goal has been to address issues of equipment getting old and how to change them and how to replace them, to introduce new features and functionalities to improve performance of plants and staff, to enhance and detect variations that could remain unnoticed. This adoption of artificial intelligence for nuclear facilities, has some technical and financial objectives. The technical objectives include how to reduce exposure for personnel within the facilities, how to enhance reliability of equipment, to avoid acquisition of safety systems, to assist with correct and timely decision making, and to enhance safety margin. The economic objectives include how to optimize the maintenance schedules, to improve availability of nuclear plants, to avoid the escalation of minor problems to major ones, and to support power operates and life extension. This initiative from the IAEA has enhanced and increased the use of information technology, robotics, the use of drone and automated systems within nuclear facilities. Next, Laura. Machine learning systems are being used effectively in many nuclear facilities today as part of systems for supporting decision making within facilities, as part of autonomous agents to power grid stability, and a part of autonomous weaponry in some cases to reduce a possible risk to human life. Specifically, the areas of use include earth monitoring of plant earth, in the sense of being able to use sensors to monitor aging, degradation, transient of data, and to ensure that the way plants are operating are effectively monitored. Also, machine learning are being used in gamma spectroscopy for ensuring that the gamma risks are effectively monitored and mapped within facilities. It's also used in optimization. It's used to ensure that decisions and decisions are effective, that are taken effectively with regard to resources within the facility. Machine learning algorithms and models are being embedded within robots and control systems to help with the facilities. Essentially, machine learning tools are acting as components within object recognition systems, speech recognition systems, and within controls. Next, please, Laura. Survey of machine learning algorithms and systems within nuclear facilities identify 5 main algorithms in use and two used to some extent. The mainly used ones are decision tree, artificial neural networks, nearest neighbor, support vector machine SVM, based evolutionary algorithms, and fuzzy logic. From among the artificial neural network to being used, the deep neural network is the one that's mainly used, and this is algorithm in which you have multi-layer neurons that are used. Effectively, convolutional neural networks are the most used, and these are neural networks that are based on the MAMA vision system, and essentially it is used in object recognition components. The other multi-layer artificial neural network that's also used is the recurrent neural network, and this deals with the issue of memory, the issue of contextual understanding of the model to be able to take decisions. This leads to long short-term memory system in which we have which has helped natural language processing within the system. So these algorithms help to power models that are used in several components within the nuclear facilities. Next, okay. So nuclear facilities are using machine learning algorithms, but we need to understand what are the threats aspects, what are the vulnerabilities that are associated with the use of these machine learning systems. Pepnot and Goodfellow have carried out a number of studies to look at machine learning and the threats and the vulnerabilities that are available, and indicates this threat model taxonomy that I'm showing on the slide. On this threat model taxonomy, we see the adversarial goal. A threat model is actually a risk-based analysis of a system that gives you an idea of what are the potentials for attack, and what are adversaries and what could they be doing. Next. Next, please. So the attacks are actually exploratory attacks, evasion attacks, and poisoning attacks. Next. So work on resilient machine learning have dealt with data and model manipulation by adversary. I've dealt with formal taxonomy for adversarial attack on machine learning and common language for in-depth risk analysis, devising attack vectors against specific machine learning algorithms and issues relating to machine learning security implementation. Next. The areas of focus for the work include adaptive defense against adaptive attackers, defensive distillation, benchmark of resilience of machine learning model against performance against attack, upfront machine learning security consideration in design and implementation, changing the learning process of machine learning to increase transparency, increasing the quality and quantity of resilient machine learning tools and processes. Next, please. Nuclear facilities and the applications that are run in them have been proven to be vulnerable to cyber attack. There is a report by the Nuclear Threat Initiative, NTI.org, in which they looked at, in the past 10 years, the number of attacks on nuclear facilities and indicates that nuclear facilities are not immune from cyber attacks. And the work of Pepnot and others have shown that models in nuclear applications are also susceptible to attacks. So models that are used in nuclear applications need to be capable of recovering from adversarial actions. And this is the work of resilience. Appropriate tools and processes for machine learning resilience need to be developed and effectively disseminated. And also research interest in machine learning resilience need to be promoted and supported. Next. I want to use the opportunity to please go back to the question, so to the previous one. Yeah, I want to use the opportunity to appreciate the contribution of my colleagues, Professor Carsten Mapo and Dr. Craig Epifanio. So I'll take your questions. Thank you.
Okay, well, thank you, Adebayo. If I think if people have questions, then they can write them in the chat box. Just one quick one from me. So you mentioned obsolescence on your first slide. So that's going to be a huge problem in the nuclear industry because they tend to keep things in place for long lengths of time. So how does that work with security? Because I mean, if you take an example of using say a Wi-Fi link, if you're using Wi-Fi technology that is 10, 15 years old, it's presumably very insecure now. So how can you only use old technology in these types of applications?
So there's advancement and improvement over technology, and there are usually patches that enable old technology to work with new ones. Although often when you patch things, at times they leave cracks again, which are then areas of problem. But often when you are trying to deal with old things, dealing with legacy things, there are techniques and principles for ensuring that things work together, and that works even when you deal with wireless systems or deal with networks. You deal with Wi-Fi.
Okay, thank you for that. There's a couple of questions now that have appeared. Yannick has asked one. Would you still consider air gapping an acceptable defense against modern cyber attack vectors?
No. The work that I quoted, the nuclear threat initiative report, actually looked at several facilities that have been attacked, and they find out that although many of these facilities use air gap technology, air gap defense method, they are still out. And the reason is that human beings will be the tool for passing the gap. You know, air gap technology is a defense in which you try to disconnect the nuclear facility from from the public internet. But the problem is like the one we have in India, the recent attack in India, the facility was air gapped, yet it was cyber attack, and it was found out that it was one of the employees that took disk from home and took it to the facility, and that was how the malware that did the problem happened. So I would not agree that air gapping is acceptable. I think nuclear facilities need to go beyond that.
Okay, well, that's very helpful. I think that hopefully that's very helpful for Yannick, who now needs to find some other ways to secure his systems. So a question from Claire: is there a standard toolkit for security for machine learning systems?
Well, it's an emerging area. Just as we're having tools, toolkits for developing as adversarial examples, things like the generative nuclear tool. We also have tools, increasing tools that are capable of being used, but because to define a machine learning system involves multiple components working together, it's difficult to actually have one unique tool that you can use. There are approaches, processes, and techniques that are combined to secure machine learning systems.
Okay, well, thank you very much for that. I think that there is another question from Yannick in the chat window, but I think if maybe you can answer that through the chat, and we'll move on because we're going to move on now to Race, who are going to talk about the LongOps program. And so thank you very much, Adebayo. And I think if anybody has had the pleasure of speaking to Rob Buckingham anytime in the last 6 months, you will have heard a lot about the LongOps program. So what we've asked is for Race to come along and give us a bit of an overview and to explain how others might get involved in a program. So I'll hand over to Pete and a gaggle of people from Race who are going to talk about it now.
Thank you, Barry. Good morning, everybody. Just to introduce myself, I'm Pete.Gillham, the project manager at Race for LongOps. As Barry says, I'm also joined by a number of my colleagues who have prominent roles within the work packages of LongOps. So we have Rob Ellis, who is working on work package 2, Ipek Caliskanelli, who is working on work package 3, some of the digital technology development work. Rob Sharratt, who is also working on work package 3, but a different aspect of it, around the manipulator hardware procurement activities. And finally, we have Justin Thomas and Sam Wainwright, and both Justin and Sam are working on work package 4, which is to do with training and dissemination. So I'll just start off by giving a bit of an overview of LongOps and a little bit more information around those work package activities before I hand over to other members of the team to go into a bit more detail. So LongOps. LongOps stands for long-term operations using long-reach manipulators. The project started in November of last year, 1st of November, and it's about 3.5 years long. So it's running through till 31st of March 2024, and it's a £12 million programme. So you can see from the top centre there that we have a number of fairly key stakeholders involved in the programme. We have, apart from UKAEA, we have the MDA, stroke Sellafield. We also have TEPCO and UKRI. So LongOps was awarded a £4 million grant under the ISCF competition last year. So that obviously made up a third of the overall budget, and the remainder was equally shared between TEPCO and the MDA. So just moving down to the bottom centre there, we've got a sort of overview of the work breakdown structure of the programme. Just to go into each one in turn, work package 2 is focused on task analysis and requirements capture. So Rob will speak in a bit more detail about this, but it's all about identifying and analysing tasks and use cases. By that we mean challenges, really, that are associated with fusion, which is likely to be an application at Culham. Also at Fukushima with our TEPCO colleagues, and at Sellafield as well. So obviously that's the NDA aspect of the programme. Work package 2 is very much up and running. It's on the critical path, and it's obviously very important to us because it informs a lot of the technology development work that's going on in work package 3. So looking at work package 3, this is all around developing digital mock-ups, or probably better known to most of us as digital twins. 3.1 there, architecture and standards. This is Ipek specialist area, but it's looking at developing a flexible standardized architecture for the digital mock-up, and to an extent some safety cases and guidelines as well for remotely operating equipment and tooling. Work package 3.2 is the digital mock-up development activities themselves. So initially this has been looking at a sort of training digital mock-up, which has been or will be very useful in terms of communicating the sort of capabilities and the advantages of DMUs to the likes of TEPCO and Sellafield. But then moving on to what we're referring to as a next generation digital mock-up unit. And that's very much the crux of work package 3.2. Work package 3.3 is again predominantly a research activity, looking at de-risking long reach mechanisms. So this may well include utilising the TARM at RACE at Culham, which is our telescopic remote handling system. And you'll see a little bit later in the presentation that there are opportunities certainly for industry and academia to get involved in some of these research tasks within work package 3, 3.3 being one of those. Work package 3.4 is associated with our procurement and assessment of manipulators, which again is very much underway. We've purchased, bottom left-hand corner of the slide there, 2 dual arm systems from different suppliers, which Rob Sharratt will tell us a bit more about in a minute. And this work package also looks at developing a haptic training simulator as well within 3.4. 3.5, another R&D work package looking at sensing and perception. So this is aiming to develop technologies for incorporating live sensor data into the DMU. So this will be predominantly for planning and operational support type activities. And finally, along the bottom there, 3.6, which is just a sort of assessment and validation activity for the DMU, just to make sure that it's doing what we set out to do, and it's performing appropriately for our stakeholders. Finally, on the right-hand side there, we have work package 4, which is sort of engagement and training and knowledge dissemination. So this is quite a varied work package, but typically it's looking at the use of digital mock-ups, training and task development in arduous and unknown environments. And then on the other end of the sort of spectrum, it also captures communication plans, which we're putting together for the programme. So quite a varied set of activities in work package 4 there. Okay. So I think just in summary, it's a fairly high profile project is LongOps. There's obviously international stakeholders involved in the programme. The outputs from the programme are extremely tangible, and they will be, they're being developed in partnership with some pretty high profile end users, of course, in as much as Sellafield and TEPCO. So they will be directly supporting decommissioning activities once the programme has completed in a few years' time. And there are a number of opportunities for industry and academia to get involved in this work. So I think at that stage, I shall hand over to Rob to talk to us a little bit about Work Package 2.
Good morning, everybody. Yeah, the role of Work Package 2 is to look at real-world application areas and try and pick out particular research topics which are applicable to those areas. Also to come up with concept designs to try and solve problems in certain areas. It's always nice to sort of exercise the process and come up with concept designs, and a lot of R&D ideas come out of that. I heard early on that there's a lot of interest, obviously, in the Fukushima side of things, and that's something we're going to be addressing later on in the year. But at the moment, we are looking at repurposing the jet fusion reactor that we have in the UK, also maintenance designs for the ITER fusion reactor in France. And we're also looking at some applications over at Sellafield, some decommissioning and clearing up operations. I'm going to sort of talk a bit about all of these things. From the jet side, there is a need to start dismantling the external elements of the jet fusion reactor, so top left there, and we will need to do some big cutting of very heavy items and then carefully lifting them off and moving them to various places. And we've assumed that personnel can't operate in that area for any length of time. Therefore, it's all done using remote systems. And so we have a need for a haptic robotic system that can be moved around on a crane and booms to get at certain areas to do some delicate work, but also help out in terms of some really big heavy lifting. So there's also a crane that can lift heavy items, and that needs to be managed. And so we're using a haptic device in order to be able to manage the bottom of the lift and guide the lift up. So it's quite a complex combination of delicate work and very heavy lifting and very heavy cutting for that. And so we're coming up with concept designs and identifying some research areas which could help in that kind of an application. On the inside of jet, there's also the need to be able to cut certain elements up and then categorize them and process them depending on the level of contamination and that kind of thing of each of the little bits and pieces. So we've got this idea of having to cut very precisely bits of metalwork inside the reactor and then not let them drop, but be able to sort of hold them and then place them in the right area. In order to do all that cut planning, the as-built needs to be investigated, and therefore the cut plans need to be modified in accordance with the as-built, and therefore there's perhaps the need to do some automated adjustments of cut planning allow an industrial type robot, which is very good and very accurate at cutting precise locations, be able to feed that precisely the right information. But that robot also therefore needs to work with a very delicate haptic robot, which can hold the pieces, make sure they don't drop, maybe unbolt certain things and do some delicate work around the industrial robot. Unfortunately, the haptic robots are not particularly good at doing very precise and repeatable things. So this combination of haptics and non-haptic industrial robots, quite an interesting one for that particular application. For the ITER reactor that's being built at the moment, there's something called a hot cell in there for the neutral beam systems, a very big area. And we need to get very large robots to move to certain locations, do some very delicate work and very heavy lifting work, and then be moved back. And all the bits and pieces they work on to be moved backwards and forwards, and the various tools and things moved backwards and forwards. So we're looking at robotic transporters to be able to sort of pick these robots up, move them, anchor them to the right location. Those robots to then do some very delicate work, and some very heavy lifting of major components, and those components move back to airlocks and things like that to be taken away. And so we're looking at these sort of robotic transporters you would get in, say, an Amazon warehouse, but maybe beefed up a bit in order to cope with that. And basically, it's a combination of all sorts of things going on at once, and trying to coordinate all of that is quite an interesting problem. On the Sellafield side of things, we've got a use case to look at decommissioning Pile 1 reactor, which is a sort of nuclear weapons plutonium generator from the 1950s. And the key problem there is to be able to go into Pile 1, which was damaged by fire in 1957, and extract and cut various components out of the graphite core. It's very difficult because you're trying to reach through a charge face, which has got a very small port, sort of 8-inch diameter ports, reach right the way through there, through a 2-meter void, and go right inside the graphite core, which is 7.5 meters thick, through very small holes in the graphite core, which are only 90 millimeters roughly in diameter, and go do some very delicate work in there and bring things out. That's a very difficult problem to solve in those confined spaces. So it's a really interesting problem that involves complex robotics, very delicate work in very confined spaces, while at the same time there's a working area where people are allowed to operate, which the robotics system starts from and then reaches into. So lots of complex issues there to do with how we manage that and how we solve the problem. The technique we're using is a hierarchical task analysis, which is human factors based analysis process, because a lot of these problems involve a combination of the robotic side and the human side. And in order to make that team work the best, you need to cope with the limitations and the benefits of both and working them all together. So that's sort of the key approach we're applying to this. And we're going to apply that same technique to the Fukushima application as well. We've done that 2 years ago in one of the sub areas of the Fukushima side of things, and it worked really well. And we're hoping to do a similar activity in the summer. Okay, thank you. Okay, Pete, next slide.
The IT to work. Thank you very much, Rob. Ipek, thanks for the next slide.
Hi, everyone. My contribution to LongOps is to design a system architecture and define the components for Work Package 3.2 to develop the software. What you are seeing on the left-hand diagram is a funny context diagram. Is all the external modules that we think will be inputting to the digital mockup. So some of these are the user of the system, environmental sensors, the actuators that will be in the environment, and control system that will be moving the actuators. There are potential databases that we can use to pull the data from, and also potential external simulators that are very specific to achieve certain tasks. And these can be haptic simulators and or rigid body dynamic type of very specialist areas. Most of the modules or subsystems that we will be employing within the NGDMU is quite vague, and the definitions of these probably varies a lot depending on who you are talking to. So in the diagram on the right hand side, we have identified a NGDMU box, and within that box we have planning tools, visualization, human machine interface, equipment control module, simulation, and what we call the digital twin. Most of this is what we currently think the NGDMU system will have as submodules, and the rest of the external system components are currently also mapped as you can see. So this is subject to change a lot, but currently we are in the process of defining the system functionality and what we are expecting user to do, and try to define, map these functionality into these submodules or system modules to provide these systems with those functionalities. Another key important aspect that we are trying to focus is the information exchange and the system integration side of things. We would like NGDMU to be extensible, as always, and being able to be used for decades, ideally. So trying to look into data interfaces and how the system components will be reacting, or information exchange among these components will be facilitated as well. So like I said, NGDMU is going to be a massive piece of software, and we are at a very early state of this. So this is still subject to change, but me and the team is doing a great job trying to understand what is in the market in providing these functionalities and also defining these capacities. I think that's it from me. Thank you.
Thank you, Ipek. Okay, we'll just take a quick look now at some of the upcoming procurement activities under Work Package 3. So all of these things are focused obviously on developing digital mock-ups. So I won't read each one out line by line, but generally speaking, we've got generic architectures and interfaces in there, enhancing robotic planning tools, controlling long-reach deployment booms, developing data sets for machine learning. So there's quite a lot of good opportunities there for both industry and academia to get involved in. We're looking to develop TRLs from between 1 and 5 typically. So we're certainly not stipulating by any means which tasks industry should go for and academia should go for, and which ones they shouldn't. It's an open opportunity from that perspective, and it'll also very much be a standard government procurement, competed procurement. So you can see the target start dates as well on this chart, and the sort of budgetary bands that we're targeting for each individual activity. So I think, as I said earlier, we're looking for for 2 or 3 to kick off around sort of September time this year. And then typically they're running for around 12 to 15 months or so, with the odd exception. It will be hopefully a fairly standard procurement process in terms of what we're all used to. We do have an information notice already published, a PIN. That's already out there, and we have had one initial engagement session. We're also planning to do a second one around June time. We think that will be good timing because we will have further developed the technical specifications by then for each of these tasks, of which there's normally 8, but we may be separating some of these into further smaller tasks. As it says here, we'll be publishing through Contracts Finder or Finder Tender Service. We'll make sure that we'll make this procurement process as clear as possible in that industry engagement and academia engagement session, so that hopefully the process that needs to be followed will be clearly communicated. And yes, we very much hope that you'll be able to participate in that session, and also the wider tender opportunity. Okay, let's move on to the next slide, which is Rob Sharratt with the manipulator procurement and assessment.
Yeah,
Thanks,
good
Rob.
morning. Good morning, everybody. Yeah, so as part of LongOps, we are acquiring 2 industry-leading nuclear tolerant capable manipulators. One being the Telbot from Wallischmiller, and the other being the Dexter from Veolia Nuclear Solutions. And these are very specialist equipment which are not normally available for training, research and development. So this is an excellent capability to have to allow this training and development. And you'll see we have the Telbot and the Dexter. I'll not go into the details of each of these systems, but you can visit their websites, as don't really have time at the moment. But they're essentially, what we are procuring is 2 dual-arm systems for each. Both systems have a local station, which is the human-machine interface side, and a remote end, which is essentially the robot, the action end of the system. Both systems are mechanically and control system different, so this will provide different aspects for the operator. They're both dual arm, they both have force feedback, so the operator directly feels what is being witnessed at the remote end. They are both kinematically similar, so the local station is the same geometry and joint dimensions as the remote end, which is good for operations. And we're able to operate with the local station and the remote end being greater than 100-meter distance, which is good for these LongOps operations. And we've got a payload of up to 20 kilograms at maximum reach for the 2 systems. So the procurement is ongoing at the moment. We're looking for factory testing in November of this year. And then in December, the systems will be brought to RACE to be installed on site for a site acceptance test in a test cell environment where the research and development training can be undertaken. And then in January, we'll be doing some initial training provided by the suppliers and local commissioning. And then we'll be looking to do performance trials where we'll be able to assess the different systems against each other and determine what the advantages and disadvantages of each system is. Following that, the manipulators will then be used for research and training in work package 4, which I believe I can hand over now, Pete, to Justin.
Thanks very much, Rob. Yes, over to Justin and Sam.
Hello. So yeah, Work Pack 4. It's very much based on training and knowledge capture and transfer. So we're aiming to develop the capability of UKAEA, TEPCO and Sellafield to use digital mock-ups to de-risk remote operations. DMU makes it easier to train, plan and visualize remote operations. And as a lot of you know, RACE has got a lot of experience in using this type of system for our work on JET. We've been using various versions of this setup for over 20 years now. So it's allowed us to plan complex remote handling campaigns that have run for significant durations, over a year in some cases, and it's a really key tool to our work. As Ipek mentioned, there's an output which is a DMU, next generation DMU, but an early deliverable has been a learning DMU, and it's a quick representation of what a DMU might be able to do, and it's there to stimulate conversation and give us something to talk around, to show some of the functionality and capabilities. On the right hand side is a picture of the JET remote handling control room, and it's just showing the how all of these systems integrate. There's a digital twin, there are live camera views, there's a physical haptic device for the manipulator, and we work with all these systems online with the real hardware, but also offline in a more of an office-based environment. So it's a key tool for us. Another thing we're doing is we're designing and delivering a training course for TEPCO, and TEPCO are starting their journey in remote operations, although there's been a huge amount of remote activity on the site. TEPCO are starting to, or preparing for the long-term decommissioning of the reactors, and they're taking that on themselves. So they want to build the capability, the tools, and the team to carry out those operations for decades probably. So we're supporting them with that with a training course. And we want to capture the remote know-how from JET and Sellafield. We have very similar sort of experience, but perhaps very different approaches to the way we do it. JET has been very much focused on maintenance, repair, inspection of a working fusion reactor, and perhaps a lot of the Sellafield work is more focused towards decommissioning. So actually gathering up the knowledge that both sides have got and bringing it together and should be able to benefit everybody. And again, that goes into developing the capability at UKAEA, TEPCO and Sellafield, making use of DMUs and leading up to the integration of this next generation DMU technology. Sam, I think you've got a couple of words to say as well.
Yeah, I'll keep it pretty brief given the time, but yeah, just wanted to, so I'm the knowledge transfer manager at RACE. I've been working here for about 6 months now, and I've been working closely with Justin on planning the design of this training course to TEPCO, which is obviously a really key knowledge transfer activity for us, and it's also a chance, I think, for RACE to basically write down a couple of decades worth of operations experience, get it down on paper, and that's really important for us. Even better that we can sort of transfer that over to Sellafield and TEPCO.
That's
great.
That's that for us.
Yes, thank you, Sam and Justin, for that. So Laura and Barry, thank you very much. That concludes our slides.
Right, well, thank you very much for that. And if people do have questions, please put them in the chat. I'm going to very rudely, just whilst we wait for any questions to come through, we've got a couple of events to announce. So on April the 29th, I'll put a link in a chat, but Rob Buckingham and RACE and NNL and Sellafield have been organising something which we're calling RACO Labs, and there's an event on April 29th, and we have Trudy Harrison, the MP for Copeland, who's come along, and Rebecca Weston from Sellafield. So I'll put a link so you can sign up for that, and that's about trying to establish a robotics centre up in Cumbria. And we also have our working group meetings, which are May the 5th and 6th, and we've had email reminders about those going out, so you can register for those. So back to the questions. I did have a question, Pete, and I was curious. So the digital mock-ups that you're making, are they proprietary, or will they be available for anybody to use?
That's a really good question, Barry. I will probably need to take that one away and come back with an accurate answer on that. It of course will all be captured within our IP terms and conditions with our stakeholders. So yeah, a very good and relevant question. If I may, I'll come back to you with the answer on that.
Yeah, no, I appreciate it. It's probably a difficult one because of the nature of the funding. The UKAEA bit is a bit more open than perhaps TEPCO and Sellafield might like to be.
Yes, we've got 3 separate agreements, as you can imagine.
Yes, and I heard they were very difficult to set up. Okay, well, I think thank you very much for that. There are events which you mentioned in June, July. We will try and publicise those ourselves. And I think I would encourage certainly the academics who are present to try and get involved in this. There is funding available, and I think the procurement process is a little bit different to what academics are normally used to. It's probably more something that industry is more used to, but I suspect it's worth going to the efforts, because I think the work, particularly working with some of the Japanese partners, is really fruitful and interesting. There is a question from Guido. Are consortia applications between industry and university okay? So are collaborative proposals okay?
Very, very much. Yes, we've got no prerequisites around consortiums and collaborations. So whatever industry and academia feels adds the most value is welcome.
Okay, and I will certainly be talking to Guido about trying to apply for something. Okay, well, unless there's anything else, thank you very much. Is there somewhere where people can contact you on if they have questions after this? Is there is there a website where there's more information, or is there a key contact that people can contact? Yes,
so I think 2 things. One, if it's appropriate, I can circulate more detail around the programme and the procurement opportunities, which is related to the earlier engagement session that we held. So I can do that. And secondly, I can put my contact details in the chat so they're available for everybody.
Okay, that's brilliant. Thank you very much. And thank you to Adebayo and for presentation earlier. And thank you everybody from RACE for giving us an overview.